Hello friends, welcome back on part 2 for the air intake selection. In part 1 we have seen what is the basic function problem caused by contamination benefits of the air cleaner. In the second slide we have seen the types of air cleaner available in the industry, like wet tap and dry tap, and we have seen what is the dust holding capacity and how it works. So now we continue with the dust concentration, like what are the types of the dust concentration available in the field. The dust concentration is nothing but it's a particle size available in the air or atmosphere from where it enters into the engine. So there are two ISO standards on the coarse and fine dust particles. If you see this chart, the particle size range from 0 to 5 micron, and if you are working in the fine dust environment or we are working in the coarse dust environment, the percentage of the fine percentage of the particles from 0 to 5 micron is 39%, and 5 to 10 micron is 18%, and this is the weightage of the dust concentration available with the particle size in the air. And a table 2 shows the common contaminations and micron sizes, like what are the components or available in the air is like dust, exhaust soot, smoke, cloud and fog, and these are the particle size for those contained. So the contained, which is contaminations which are available in the air, if you see this chart, these are like dust, exhaust soot, and all those particle sizes are mentioned in the chart. So if we are working with a particular air filter element for the vehicle in a fine dust environment, or if we are working in the coarse dust environment, the dust holding capacity will vary. So if you are working in the coarse dust environment, the dust holding capacity for a particular filter is very high. If you are working in the fine dust, the dust holding capacity is very low. So if you see this curve, like this is the pressure drop versus the airflow requirement for the engine, and what are the pressure drop, how it rises when the dirt is accumulated in the air, and how the restriction rises across the air intake system. If you so for the course, the similar curve is there. If we are using the same air filter elements, if we are using the same air filter element with the two dust environment, the dust versus pressure drop is very high, and the dust holding capacity is almost 4 times compared to the fine dust. It varies, actually it varies with filter to filter elements. It's just a particular example is given for the 8-inch series, based on the ISO and the coarse dust concentration uh, as per ISO standard 12103 and as per ISO standard 5011. So this is like just a DSC curve, which we are looking like, which we are using to determine the air filter element life. If you want to determine the air filter element life on this particular chart, suppose if you are working in this particular concentration environment and you want the service interval of 1000 hours, like if you're working for the 1000 hours and then we need to clean the air filter element, then if you will plot based on this, and if you will plot based on the horizontal as well as vertical axis, so for 1000 hours and for 0.25 dust concentration environment, you need to complete at least 9 or 10 hours lab life in the test lab, so that the particular filter element for the coarse dust, for this coarse dust environment, and if you need for particular CFM, you need the 1000 hours service interval, you need to at least pass the 9 hours lab life test. So if you will see the here example, like how the target life in hours of operation, suppose the dust holding concentration in the medium is 0.25, or and so if you need to calculate like for how many hours, the suppose your dust holding capacity is 4 kg for the particular filter element, and you are working for the dust concentration environment, and your flow rate requirement for the engine is here, so you will get the approximate 983 hours for the service interval for the particular filter element selected for this airflow rate, which came from the engine spec. So this is just an example where we have seen like how we calculated the service interval for the particular air filter element. If you know all those parameters, you can calculate based on the same. So now we come to the pre-cleaners. Why we need the pre-cleaner? So to increase the service interval of the air filter element, invention went on for the air filter for the pre-cleaners, which will place in front of the air cleaner element or air cleaner body. So it increased the service interval for the filter element. How it works and what types of pre-cleaners are available. So the first type is air ramps. This is effective in removing dust and water at high speeds. So this is generally used in the automobile sector or the on highway equipments, and this is the inline separator. So it is often used for the second beginner of a non for on highway vehicles, effective of removing large dirt particles or water at speed. Now come to the third type is the collection ball and the full view pre-cleaner. So this is like very cheapest pre-cleaner which we are using in the construction or of highway vehicles. Like it's just collecting the dust from where dust in the bowl, in the transparent bowl, and from the vents are provided in this part. So the air is passing from the vents and it is passing through the bowl, and it is going inside from this pipe to the air filter element. So the dust will collect in this transparent bowl. So it's just angled vents cause the incoming air to spin rapidly around the pre-cleaner, and the dirt water is collected to the outer bowl, and clean air passes to the air cleaner outlet. This efficiency for this type of pre-cleaner is like 75%. If you consider like 100% of dust, 100 gram dust is coming from the air, so 75% it will collect in the pre-cleaner bowl. The next generation pre-cleaner is like turbo spin or self-cleaning air cleaner. This is now generally used in a heavy dust environment where the self-cleaning is required. So this is nothing like just a turbo. This is just like a rotating vanes where the air is coming in from the vanes, inclined vanes, and it from the speed of the suction, from the speed of the air, which is created by the suction of the engine. The rotating vanes will throw the heavy dust particles outside the pre-cleaner. So there are some vents, opening vents in the pre-cleaner from where it is throwing out. So the efficiency for this kind of pre-cleaner is 85%. And how it works is like rotating vanes separated dust outside the pre-cleaner, increase the level of incoming air restriction, but best suited to slower moving. Now the third one is like how to increase the or more service interval life for the air filter elements is like scavenging process. What is scavenging process? What is scavenging process is like air dissipated strata cap or vacuum scavenging. So scavenging is nothing like it's also in the air intake chamber where we scavenge the exhaust gas from the incoming airflow. So if we talk about the scavenging in the air filter element or in the pre-cleaner, it's nothing but it's integral part of the air cleaner where the heavy dust environment which is collected in the pre-cleaner, it sucks by the exhaust gas. Due to the pressure difference, the dirt will go from the exhaust outlet which is collected in the air intake pre-cleaner or in the air intake body. This is scavenging process is also included in the air intake body sometimes, or it's also included in the pre-cleaner. There are different types of designs available in the market based on the dust concentration or the packaging environment. The operation efficiency for this type of pre-cleaner is 95% and usually used in the conjunction with an exhaust scavenging system to clear away the separated contamination. Now we talk about the pre-cleaner efficiency. We have already seen like the strata cap scavenging system, Donaldson donor spin scavenge system, top spin HD. So there are so many pre-cleaner suppliers like Donaldson, Freedguard. Many suppliers are there, and they have their own design and spec. So this is just a curve which I got from the internet. So like how the separation efficiency increase with the type of system available in the pre-cleaner. So this is nothing, just a dust unloader wall. Why we need the dust unloader wall? So we don't need to open the air intake body again and again, so that sealing between the air filter element and the air intake body will so the sealing between the air intake body and the air filter element will reduce. So just a dust control valve, which is which is nothing like a rubber flap, which we open generally to drain out the dirt accumulated in the air intake body. So we don't need to clean the air filter element regularly, but it will increase the air filter element service intervals. Scavenging advantages, we have already talked about what is the scavenging. So scavenging is like nothing, high peak in efficiency, longer filter and service life. It's a completely self-servicing and self-education which is created through the exhaust system, through the pressure drop which is available in both the system. So the secondary airflow to the drop tube on the air cleaner used as ejector or muffler. So if you see in this diagram, it is clearly clearly identified like how the air is going inside and how dust is incremented in the dust unloader valve, and from where it is ejected through the exhaust gases. Now what are the compact air cleaners? There are lots of compact air cleaners available, which is like a power cord filtration technology, which which is created because of BS6 emission norms, because of the because of the concern or complicated packaging requirement. We need a small types of air filter element which contains more and more dust, so the dust holding capacity should be high. So there is a power core filtration technology available, where like the fluid kind of design and the separation and the dust gets separated here. So when the high velocity air passes through the veins and it hits to the wall, the dirt will get accumulated here and the air will passes through the another channel. So what are the power core technology, what are the compact type of filtration available? It depends on the company to company, and we have to select based on our packaging. And this is almost in compact in size. So if we talk about the performance advantage, this is smaller in size, lower pressure drop across the system, so we will get more pressure drop range to get more filter element life, longer, more efficient than average conventional. Pleated filter expansion or contraction pleat reduced during servicing, dirt won't sludge. So this kind of filter elements will also not, the pleat aqueous piece will not get damaged when you clean this type of the filter elements. And there are particular process how to clean the filter elements that's given in every service manual with the different companies and with different OEMs for the particular vehicles. And what are the dust holding capacity? Like if you will talk about the dust holding capacity for the same size of the filter elements for the compared to the power core and the conventional type, it's almost two times of the dust holding capacity if we compare about the conventional type. And overall efficiency, yes, definitely the power core, the new filter elements which is developed by different companies, they are very high in efficiency. So come to the challenges, like what are the challenges in installation for the air filter elements? So it should be definitely, it should be away from the exhaust gases which is ejected by the engine itself. Also the direction of the air filter elements is 180-degree apart, or it should be very far away from the exhaust gases, and should be protected, should be properly clamped, so the air intake body should not get damaged. What are the need to place where the cool air is available, so the more volumetric efficiency will get in the engine. It should be with the clean air available, mounted in a location where the minimum vibration occurs, so the body will not damage, and the body should contain those much vibrations in the duty cycle for the particular equipments or vehicle for the duty cycle which is defined for the vehicle. So orientation of the air cleaners likely minimizes to restrict the water entering, so the water or the moist should not get into the engine. So the vane or the PK is designed in such a way so the dust or the air which is passing, which is going into the air, which is going into the engine, should not carry that much moisture, or raining water should not enter into the engine. So the power core air filters, like it's very challenging to place the power core filter elements in the BS6 vehicles where the high temperature air intake requirement is there and the high temperature requirement is there. So solution for that is like to prevent the compartment for the some separation, like inside the hood as well as the grill side vents to connect with the air intake body. So this is like just an example like where we do the testing for the air filter elements with the dust feeding to the beginner. So the dust holding capacity should be calculated as well as the life of the air filter element is calculated, and it depends like how much service interval is required for a particular application based on the CFM requirement. So your pressure drop across the system should not exceed. Now in the air filter elements in the BS6, like there are so many components in place. One is the air intake restrictor. So this we will discuss more in the next video, which will be continued for the part 3. Till that we have completed this much information, and there are so many informations available for the air intake, like what are the do's and don'ts, what are the no components added in the BS6 emission norms. So if you do like this video for a particular information and a particular selected information which is required for every designers or very engineers to carry with his mind, carry with a special note like how to select the air filter elements, what are the key points, please do like and subscribe my video, so I will continue with the same passion to create the new videos for you based on the exhaust system, based on the noise, based on the engine selection, based on the transmission. It's only depends on when you will do like and subscribe my channel. Thank you everyone.